we want to check whether this function is continuous and differentiable at x equal to 0 or not. We will just use the definition. So recall that if a function is differentiable, then it must be continuous. And if it is not continuous, then for sure it is not differentiable. So we check this one first and see whether it's continuous or not. If it's not continuous, we don't have to check the second one. So check continuity. We want to check whether, recall that the definition. F is continuous at x equal to a, in our case x equal to 0, if the limit f of x tends to 0 exists, and it's equal to f of a, f of 0. So f of 0 must also exist. In our case, it exists, and it's equal to this limit. This limit must exist. This limit exists. We have the limit f of x tends to 0, minus equal to limit f of x tends to 0 plus. So 0 is here. X tends to 0 minus, and x tends to 0 plus must be equal and equal to f at 0. So we compute that limit. In this case, it involves function psi of x or psi of 1 divided by x. You can use the squeeze theorem here. So first of all, f of 0 is 0, or by definition of f. So that's the first thing. The second thing, we want to check whether this limit exists, whether the two are equal or not. So in this case, we have f of x equal to this. This is less than or equal to x times 1. Sine of x, or sine of whatever is here, 1 divided by x, always less than or equal to 1. Bigger than or equal to minus 1. X times minus 1. So for all values of x different from 0, it's defined by this formula, and this formula is always less than x, bigger than or equal to minus x, and x. The limit when x tends to 0 of minus x is 0. The limit when x tends to 0 of this x equal to 0. And by the squeeze theorem, we know that the limit of this one when x tends to 0 must be 0 by the squeeze theorem. So this is 0. So the limit f of x when x tends to 0 in this axis is equal to 0. We don't need to compute the right hand limit and the left hand limit. By the squeeze theorem, we know this is 0, and it is equal to f of 0. So the limit exists and equal to f of 0 by definition. F is continuous at x equal to 0. So now we will check whether f is differentiable at 0. We use definition again. So recall that f is differentiable at x equals 0 if the limit of f of 0 plus 8 minus f of 0 divided by 8 tends to 0 exists. We compute this limit. So limit of this equal to, by definition of the function f, limit 8 tends to 0. Up there we have x. In our case, x is just 0 plus 8. We have 8 sine 1 divided by 8. That's the definition of the function f. Minus f of 0 is 0. This is limit 8 tends to 0 sine 1 divided by 8. So 0 here. We have 8 divided by 8 cancel out. What's left is 1 divided by 8. This limit does not exist. Sine of this does not exist. And by definition, f is not differentiable at x equal to 0. Now let's change the question a bit. We have this. But now the definition of function f is x squared times sine 1 divided by x. Then this function wouldn't be differentiable at 0. So when we check the continuity, you have x squared sine 1 divided by x less than or equal to x squared bigger than minus x squared, because sine of x is bigger than or equal to minus 1, less than or equal to 1. Again, we use a square theorem. This one tends to 0, this one tends to 0 when x tends to 0. Square theorem says that this limit when x tends to 0 is 0. So limit of f of x tends to 0 exists. Exists, and it is equal to f of x, f of 0, so equal to 0. So first of all, this function is continuous at 0. And I check the differentiability. We use definition again. We compute the limit when 8 tends to 0, f of x plus 8 minus f of x. In our case, we want to check at the point 0. So 0 plus 8 minus f0. We want to see whether this limit exists. So in our case, limit 8 tends to 0, f of 8, by definition, s squared sine 1 divided by 8, f of 0 is 0, so limit 8 into 0, s squared minus divided by 8 sine 1 divided by 8. So yeah, we just did that limit of that, this limit, so a limit of that here, 8 sine 1 divided by 8 tends to 0 is 0. Yes. We just did that computation by the square theorem. This one equal to 0. So this limit exists and it is 0. So that means that by definition f is differentiable.